Today we're going to talk about solving polynomials using division. And oftentimes what I find is with the steps listed out is that people don't really hear what I'm saying on these. But I do want to go through them for a couple minutes, because if you get stuck sometimes when you're working on a problem, it's always good to look back and see what are the steps here. So when we take a look at this, the first one to do is we check and see if the polynomial can be factored. And if so, we'll factor it. That's the quickest and the most efficient method. But not everything is factorable. So we're going to use our graphing calculator to help us find some of the roots. And the thing is, we can see roots on the calculator. What we can't tell is if they're irrational roots. That's the non-repeating infinite decimals. We can't tell those yet. Then we're going to use the root and apply synthetic division to it until we can get to a quadratic format, because we know how to solve something in quadratic format. We can solve by the quadratic formula. We could even use completing the square if we wanted to find our remaining roots. And then finally, all of our solutions should be written in exact form, which means it's going to be in simplest fraction form and or simplest radical form. Make sure that you have as many solutions as the degree of the polynomial. So when we take a look at this first problem here, when we look at it, it looks like maybe we can factor, except that we've never factored with something with x to the fifth, and x to the fourth, and x cubed, and x squared, and x and 4. So since we're not sure how to factor this problem, let's go ahead and type this into the calculator. I actually already have them typed in. But if we go to our calculator and we look at our y1 in case of mine, typing in this function, x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4. We type that into our calculator. And then when we hit graph, we get that picture. As we take a look at this, can we identify any of the roots, also known as x-intercepts, of this function? And hopefully some of you are nodding yes. But as we look even a little bit closer here, if you can't tell on the picture, I can see that -2, 0 is a root, 1, 0 is a root, and 2, 0 is a root. They're oftentimes called zeros of the function because the y value is always 0. So what we see either in the picture, and I want to go back to that, is -2 and 1 and 2. Those are all values that we can see on the calculator. Exact x-intercepts we can see on the graph. Looking back at the picture, -1, -2, +1, +2, pointing to those specific values on the graph. But once we determine these values, then we can use these values to help us come up with all of the roots of the function. How many roots are we looking for?
5.
Looking for 5. The highest degree of our polynomial is 5. That's why we can look for 5. And the way that we're going to come up eventually with our quadratic to help us find our other roots is we're going to use synthetic division. You can use long division if you would like. It will take you a little bit longer probably. And here's what we do. Make our upside down division bar. And we're going to put our coefficients in of our polynomial. The coefficient of x to the 5 is 1. Coefficient of x to the 4th is -1. The x cubed is -3. Of x squared is +3. Of of x is -4 and then our constant. We do not need to change the sign over here with our roots. We're just going to use the root. If it was written as x plus 2, then we would write it if it was written in factor form. But we actually know the root. So I'm going to start with -2. And it doesn't matter which one of these three that we start with, we're going to do all three. So if you wrote them in a different order, eventually you will end up at the same place. We'll bring down our first term of the 1. -2 times 1 is -2. And -1 minus 2 is -3. -2 times -3 is +6. And -3 plus 6 is 3. -2 times 3 is -6. 3 minus 6 is -3. -2 times -3 is +6. And -4 plus 6 is 2. -2 times +2 is -4. And 4 minus 4 is 0. And if you remember, that last position here is the remainder. And what we asked last week in our notes was, is -2 a root? Well, we asked if we asked if x plus 2 is a factor. And because our remainder is 0, we said yes. So what we see here is because our remainder is 0, -2 is truly a root of this polynomial, and we've proved it. But what we started with here is we started with a polynomial that was x to the 5th. And when we divided, now we're at x to the 4th. And we need to keep dividing until we get to a quadratic. So don't change anything here. We're going to go through this process again with our synthetic division. And let's use our next root, which in this case is 1. So we're going to carry down that 1, the first term in our synthetic division. Good practice for our quiz that's coming up. 1 times 1 is 1. It was +1 times +1. -3 plus 1 is -2. 1 times -2 is -2. And 3 minus 2 is 1. +1 times +1 is +1. And -3 plus 1 is -2. And 1 times -2 is -2. +2, -2 is 0. Again, we can write +0 or -0. It doesn't make any difference because 0 doesn't really have a sign. But we better end up with 0. If 1 is truly a root, then we better get 0 when we divide at the end. And we do. But the thing is, we start with x to the 5, then we drop down to x to the 4th, we divide it again. That means this is x cubed. We want to turn it into a quadratic for us to solve this problem. So we're going to divide again. We're going to use our third root that we have listed. And again, it does not matter which order of the roots you use, we will end up in the same place. So if you started with 1 and then did 2 and then did -2, you will still end up at the same place. So we're carrying down now our first value here, the 1. We're going to multiply. 2 times 1 is 2. Negative 2 plus 2 is 0. Again, I tend to write plus 0. You can write minus 0. It's not going to make any difference because 0 doesn't have a sign. 2 times 0 is 0. And 1 plus 0 is 1. 2 times 1 is 2. And negative 2 plus 2 is 0. Again, by getting 0 as that final value in our division means that we do not have a remainder, and consequently 2 is a root of the polynomial. And we prove it algebraically by what we've just done with our synthetic division. And now what's happened here is we divided, we are down to x squared, and x squared is a quadratic. And we can put our polynomial, or put our variables back into our polynomial, and we get 1x squared plus 0x plus 1. And typically what I would ask is, do we really need that 0x? No. So what we're going to solve is x squared plus 1 equals 0. And now we'll solve. We still have 2 roots to get. Someone told us that we need to be looking for 5 roots, and we do because our highest degree term is 5. We're going to subtract 1 from both sides. And we get x squared equals negative 1. The inverse operation of squaring is square rooting. So we end up with x equals, well, what's the square root of negative 1? 5. And in fact, it's going to be plus or minus I. And as we finish by filling in the box here, we were able to find 3 roots on our calculator. The negative 2, the 1, and the 2. We also have positive I and negative I. I am fine with you writing plus or minus I for a solution. But we said 5 roots. 1, 2, 3, 4, 5. We have all 5 of them individually listed. And that's the process. Let's take a look at the next one. When we look at this, it says find all the roots of the polynomials, write the answers in exact simplified form, and show our algebraic work. Well, can we factor x cubed minus 5x squared plus 17x minus 13? No. So what we're going to do is we're going to take that value and we're going to type it in the calculator. And when we type it in, we get that picture. So what we have here is the only root that we can see. And if you can't tell what it is in the picture, go to the table. Well, 1, 0. Listed there in the table. So our one root, our one x-intercept that we can see is 1. How many roots are we looking for? Looking for 3. So what we're going to do is we're going to use our synthetic division with that value of 1 that we just found on our calculator. The number in front of the x cubed is a 1. Number in front of the x squared is a minus 5. Number in front of the x is 17. And then our constant is minus 13. Carry down the first term. 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. 17 minus 4 is 13. And 1 times 13 is 13. It was positive 1 times positive 13. But luckily enough, we have negative 13 plus 13, which gives us 0. Again, when we get that 0 as our remainder, that means that 1 is a root. It is a 0. It is an x-intercept. We started with x cubed. When we divided, we ended up with x squared. And because of that, we now can use the quadratic formula or completing the square to come up with our remaining 2 roots. It's x cubed, so we need to have 3 roots. So let's put our variables back in. And we get x squared minus 4x plus 13 equals 0. Again, we'll be using the quadratic formula. A is 1, B is 4, and C is 13. The opposite of B, plus or minus the square root of B squared, and I need to put my right value for B there. B squared minus 4 times A times C, all divided by 2 times A. So make sure you didn't do what I did, which is I didn't put the negative in front of the 4 for the B value. I managed to correct that early on. But double negative gives us a positive. And some of you didn't even write that. Some of you immediately wrote positive 4, and there's nothing wrong with that. We get 4 plus or minus. Remember, if you're typing in negative 4 squared, you must have parentheses. It's going to give us 16. And 4 times 1 times 13 is 52. Divided by 2. Well, 16 minus 52 is negative 36. Divided by 2. There. We need to simplify. The square root of 36. Square root of negative 36, I should say. What's the square root of negative 1? I. What's the square root of 36? 6. So when we simplify this, it's going to be 4 plus or minus 6i divided by 2. And as we look a little bit closer here, we see that we can do one more step to this. Because 4 and 6 and 2 are all even numbers, if we divide 4 by 2, we get 2. If we divide 6i by 2, we get 3i. And now we have all 3 roots. Our 1, which we found way back at the beginning on our calculator. And then we came up with 2 plus or minus 3i, which is 2 plus 3i and 2 minus 3i. And there's our 3 roots. There they are. If you prefer to write 2 plus or minus 3i, that's fine with me. No issue with that. But one more problem here before we do a little practice on our own. First thing that we look at is, can we factor this? Well, it doesn't look like it. So if we can't factor it, then what we're going to do is we're going to go to our calculator and we're going to type it in. So we're going back to y equals. And we graph. We typed it in, we graph. So this one's a little bit more interesting. We can see one of the roots pretty easily. And then the other one, we kind of have to make a guess. But let's talk about how we can check that with our calculator as well. What's the root that we can tell? 1, 2, 3, 4, 5. If we're not sure, go to the table. 50 is listed on the table. So our root there is 5. But the other root, go back to our picture. What does it look like? Matthew? 0.5, he says. Well, we can check this hypothesis. If you go to second and trace, remember we have the 0 function in our calculator. It's hard to do on this problem, but so there's the first time I see the cursor. So I'm going to go back one. I can't see it there, but I'm going to hit enter. And then I'm going to hit it again and hit enter. So it's very close there. And I hope this works. If it doesn't work, I'll try it again. Yep. Let me try that again. Sorry about that. One more time. Second, trace, 0. So there's that. I'm going to go left. Maybe I'll go left one more time. Enter. So there you can see the dotted green line a little bit to the left. So there it shows up, but I'm going to hit it one more time. And then I'm going to hit my enter. So that dotted line, it's just a little bit to the right. And then we hit enter. And sure enough, Matthew's prediction was 0.5, and there it was. A little bit harder than it needed to be, conceivably. But now we can see 0.5, which I'm going to write as 1/2. How many roots are we looking for on this problem? Looking for 4 of them. So when we come back over here, we're going to set up our synthetic division. The number for the x to the 4th is 2. Number for the x cubed is 1. Number for the x squared is negative 35. Number for the x, minus 113. Plus 65, our constant value. And we're going to use 5 to divide. 5 times 2 is 10. 1 plus 10 is 11. 5 times 11, positive 5 times positive 11 is positive 55. Negative 35 plus 55 is 20. Positive 5 times positive 20 is positive 100. Negative 113 plus 100 is negative 13. And 5 times negative 13 is negative 65. Positive 65, negative 65 is 0. And again, what we just did is we proved that 5 is a root of our polynomial function. But we started with x to the 4th. And when we divided now, this is x cubed. And we need to have our polynomial in quadratic form to use our techniques. So we're going to divide again. And this time we're going to use the 1/2, or you can use the 0.5 if you prefer. Carrying down the 2. Half of 2 is 1. It was positive 1/2 times positive 2, which is positive 1. And 11 plus 1 is 12. Half of 12 is 6. It was positive 1/2 times positive 12, which is positive 6. 20 plus 6 is 26. Half of 26 is 13, it was positive 1/2 times positive 26, which is positive 13. And negative 13 plus 13 is 0. And when we finished this problem here, we just did prove, first of all, that 1/2 is a root. Our remainder was 0. And our function now is in the format of x squared. So if we put x squared back into the problem, we have 2x squared plus 12x plus 26. So we just put the variables back into the problem here. Yes, there's a GCF of 2. But let's not worry about that right now. Let's just talk about A is 2, and B is 12, and C is 26. And we'll put that back into our quadratic formula. Remember, we're looking for 4 roots. We found 2 of them on the calculator. We need all 4. If you should happen to be able to find all 4 on the calculator, then you just need to do a lot of synthetic division to prove that the answers are correct. It's going to be the opposite of B. Plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. When we simplify a little bit more, we get negative 12 plus or minus 12 squared is 144. And 4 times 2 times 26 is 208. Divided by 4. minus 208. 144 minus 208 is 64, and it's negative. Divided by 4. And we need to simplify. Well, the square root of negative 1 and the square root of 64. What's the square root of negative 1? What's the square root of 64? 8. So when we simplify that, we get negative 12 plus or minus 8i over 4. And as we look to finish here to find all 4 of the roots, what I hope we notice is that negative 12 is divisible by 4, and 8i is also divisible by 4. So we can simplify this one last time. Negative 12 divided by 4 is negative 3. 8i divided by 4 is 2i. So when we go back and we fill in our box, we were able to find at the very beginning our roots of 5 and 1/2. Again, if you write 0.5, that's fine with me. And then we have negative 3 plus 2i and negative 3 minus 2i for our remaining roots.